simulate the right-hand side completely and get the left-hand side. Okay? And the way you do it, it's so interesting. Okay? So our right-hand side, we have 2 divided by sine squared theta. Okay? Now, if you look at the left-hand side, we have got cos here and we have got cos there. I know from my algebra that if I multiply this denominator, let me highlight it. Hey, can you pay attention? If I multiply this denominator and that denominator, I know that I will get a difference of 2 squares. Okay? And that difference of 2 squares is going to be 1 minus cos squared what? Theta. Which means I need to convert this sine squared theta to 1 minus cos squared theta. Okay? Let the question itself guide you. Okay? So you look at your left hand side and see how is the denominator on the right hand side related to the denominators on the left hand side. They are related by virtue of this fundamental identity. Sine squared theta plus cos squared theta equals to 1. So I can convert that sine squared theta to cos. Okay? Then, if you look at the numerators, can you look please? Sometimes you just have to sit and look. You sit and look. No writing, nothing else. The left-hand side, our numerators are 1 and 1. Okay? Now, for you to be able to add those numerators, you must have a common what? Denominator. That's a basic concept when you are dealing with fractions. So to get these 2 here, you have to add 1 and 1, then you get the 2, but there must be a common denominator. And that common denominator is going to be 1 minus cos squared theta. That's the common denominator. Okay? Now, this is very interesting now. Okay? It's very, very interesting. Now, this denominator, I can write it as 1 minus cos theta times 1 plus cos theta. Okay? Now I'm almost there and I'm smiling. Now, if you remember quite well how you work with fractions when you're finding the LCD, okay, in algebra, okay, it's like this. If I give you, say, 2 over x plus 1 plus 6 over x minus 2. Okay, if I ask you to simplify that, do you agree with me that your LCD will be the product of the denominators? Yes. Yeah, so this, now check this. This 1 minus cos theta here is like this x plus 1. And this 1 plus cos theta is like the x minus 2. You just multiply the denominators. Right? Then the numerator now, we break it up into 1 plus 1 all over 1 minus cos theta times 1 plus cos theta. And I'm almost there. Then from here, we just write this as 1 over 1 minus cos theta plus 1 over 1 plus cos theta. So therefore, the left-hand side is equal to the right-hand side. What do you mean break up this one?
1 over 1 minus cos theta plus times 1 over 1
Okay. Alright. The best way that is to take you back to algebra. See that expression which I have. Let's go to the next page. So I wrote 2 over x plus 1, don't worry, I'll come there, divided by 6 over x minus 2. If I ask you to simplify this, I'm sure you agree, for you to add the 2 and the 6, you must have a common what? Denominator. And what's the common denominator? You see, Rn is the product of the two denominators. Okay? It's the product, isn't it?
Yes, it is.
Hey, you see, some of you, you see now, some of you are not paying attention, you're looking down and all that. And then when you get a question like the one which I'm doing now in a test, you can't do it. Who are you to blame? You blame yourself. So here, we end up having 2 plus 6 over x plus 1 times x minus 2, which will give you 8 divided by x plus 1 times x minus 2. Are you following it? Okay, listen, if you don't understand what I'm doing here, then trig is going to be a problem. Yes, I'm being honest with you. If you can't work with algebraic fractions, proofs of identities will be a problem. Alright, before I go back, are you following what I just did here? Huh? Yes. What?
So, why didn't you multiply the numerator with what you added?
Okay, right, I get what you mean. Right, in that case, I think I end up talking too much. All right. Okay. Right, I was supposed to multiply. Yeah, you know your stuff. Okay, you know your stuff. Okay, that was the correct way. Then you get 2x minus 4 plus 6x plus 6. This will be all over x plus 1 times x minus 2. Right? So that will give you 8x plus 2 over x plus 1 times x minus 2. Well, I can remove brackets and then simplify. All right. So, what has happened here? We went backwards, or rather, I would say, we found the LCD. Okay, our LCD is the product of those two. Now, if you go back to this question now, okay, if you go back to this question, the way it is different is this. From the previous question, our numerator here is a constant. Okay? Our numerator is a constant. So if I can break it up and get 1 plus 1, right? If I multiply, can you pay attention here? If I multiply this denominator by 1, and then multiply that denominator by 1, the two cos's are going to cancel out. Do you agree with me then? Yeah. So for this question here, it is a bit unique because the minus cos theta and the plus cos theta, when you add them in the numerator, they will end up giving you a 0. So you end up being left with 1 plus what? 1 plus 1. Maybe I need to add that step.
So, if you only break up the denominator and numerator with this multiplication.
Yeah, but you see now you have to consider this. You see what happened from here to there. You multiply this numerator by that denominator, this denominator by that numerator.
So the denominators were a plus and a minus the same number on either side.
They will cancel out. Right? So for this question now, they cancel out, but maybe I need to just add this step. Okay, to avoid unnecessary confusion. Okay, to avoid unnecessary confusion. So I'm going to add this step here. Okay, so from here I could write 1 times 1 plus cos theta, right, plus 1 times 1 minus cos theta. This will be over 1 minus cos theta times 1 plus cos theta. When you remove brackets in the numerator, this positive cos theta and that minus cos theta will cancel out, and eventually we can end up having 1 plus 1, but the denominators will be these two. Is that okay now?
Yes.
Okay. Alright, I'm sorry that I end up talking too much, then I forgot to do it.
Okay, sir.
Alright, so from now on, okay. From alright. So as a class exercise, 1 minus 2 sine alpha cos alpha, right? This is all over sine alpha minus cos alpha. Please remember, when you are proving identities, you have to apply concepts from algebra. Factorization is one of them. You have to know your algebraic fractions. Okay? Those are key concepts. The reason why trigonometry becomes challenging to most people is because their algebra is not very strong. Okay? So, now this is interesting. Now, I have told you before about those of you who pay attention. Okay? Some of you don't pay attention. See, when I'm standing in front of you like this, I can tell you who is really paying attention and who is not. Yes. If someone is sitting at an angle, it's not a good thing. Okay? Yes. Your knees must be perpendicular to the front of the classroom. Okay? If you sit at an angle like that, you are not really in the class. Okay. So the position of your desk is a little bit different. Someone who is sitting at the back, they sit at an angle. Why? Sit straight. Okay. So first thing here, if I want to create the sine alpha plus the cos alpha in the denominator, I need to create a trinomial in the numerator. Okay? To create the trinomial must be factorized. It must be a trinomial which can be factorized. Now, that's very simple. You convert the 1 to sine x, sine squared alpha. In this case, it's alpha. Please, it's not x. The Greek letter there is alpha. So it will be sine squared alpha plus cos squared alpha minus 2 sine alpha times cos alpha. All over sine alpha minus cos alpha. Okay, everything starts from algebra, right? How many of you remember? I think I told you before, but I'm going to repeat it again. Yes. When I spoke about perfect square trinomials. Huh? You remember that, right? So look here. If I give you something like this, and I ask you to expand it, you get x squared plus 2xy plus y squared. If I give you x minus y squared, you get x squared minus 2xy plus y squared. Okay? Are you following that? Now, if we compare that and the question that we have here, this denominator is like the x minus y. Okay? It's like the what? The x minus y. Right? Then, the numerator now, I need to create a trinomial such that this sine alpha minus cos alpha can be cancelled out. Okay? Alright? Are you following that? Huh? Right? So, for me to be able to do that now, I need to remember my knowledge of perfect square trinomials. Okay? But now I'm seeing that if I convert 1 to sine squared alpha plus cos squared alpha, if I simplify this, if I rearrange it and simplify, I'm going to get something which looks like this. Okay? Now, I'm sure you can see that on the right hand side is the numerator. I've got sine squared alpha minus cos squared alpha. Do you see that? Huh? So, for me to carry on and be able to get the sine squared alpha and the cos squared alpha, if I factorize this and write this as sine squared alpha, okay, that would be minus 2 sine alpha times cos alpha plus cos squared alpha. This is all over sine alpha minus cos alpha. Right? If I factorize it, that numerator, I will end up getting sine, and there's a minus here, so I'll get sine alpha minus cos alpha. This will be all squared divided by let me get one. Divided by sine alpha minus cos alpha. This will give me sine alpha minus cos alpha. Do you see that? Huh? Then now, from here now, can you look please? From here, I need to create in the numerator that difference there. I have to use a mathematical manipulation to do that. Okay? Now, the mathematical manipulation now, I need to multiply this by 1. But when I do it, it's going to be like this. Please make sure you look at, because you might end up missing it. So, I stopped at sine alpha minus what? Cos alpha. Now, if I multiply this by 1, okay, but my 1 is going to be equal to the conjugate of this, which means I'll put a what? A plus this. So this will be times sine alpha plus cos alpha all over sine alpha plus cos alpha. Okay? It's not squared. I'm just multiplying. Okay? Please be aware that I may have to put brackets here. Okay? And then I can put that in brackets. So that when I multiply, remember the denominator here is a what? Can you look please? Numerator and numerator, I'll get sine squared alpha. And then I'll get plus sine alpha. Okay. I hope you're aware we can create a difference of 2 squares. You're aware of that?
Yes.
Okay, so let me just go straight to the difference of 2 squares. So that will be minus cos squared alpha all over. Denominator times denominator. I'll get that. And then I'm done. So, left hand side is equal to the right hand side.
When getting a common denominator, what times is it? So when it
Be very careful with what you just said, because we have multiplication here. What you are thinking is when there is addition and subtraction. In this case, we have what? Multiplication. We don't need the LCD. Yes. Wait.
That was from the last thing.
I don't know, but here.
Yes, so the answer, why do you have it?
Okay. Hey, can you pay attention? She's asking something. Maybe some of you are at the same wavelength as that. Look, how many sine alpha cos alpha do we have? We have how many? 2, right? In the denominator we have what? 1. So one of these 2 cancels with the denominator. Do you see that? One of these 2. Okay, let me use a different color. One of these 2, there are 2 of them, 2 binomials that are identical. Where do they come from? What? And what is it called? Yeah. So one of those 2 cancels with this denominator because they are the same.
Oh, I get it.
Then you get this. There's no pictures. Okay, listen. Please do yourself a favor. You need to come out of this lesson understanding what I just did. Okay. Can you pay attention? Alright. This question is a little bit higher order. Okay, on proofs of identities. Now, when you are doing proofs, always look at the other side. Okay? Let the question itself guide you. So I chose the left-hand side. Okay? But I know my perfect trinomials. Alright? So if I convert the 1 to sine squared alpha plus cos squared alpha, I'll create a perfect squared trinomial. How do I know that? It's because of this. This term here, that term, it gives me a clue that I can create a perfect square trinomial. You see it here.
Which term?
You see that? Okay? Now, because of this one here, if I convert it to sine squared alpha plus cos squared alpha, I will be creating this x squared and that what?
Y squared.
And that y squared. Okay? The good thing about this is, once I factorize it, I'll get an expression which is equivalent to the denominator, which is sine alpha minus what? Sorry, in our denominator is sine alpha minus cos alpha. So one of the 2 factors cancels out with that denominator. Then from there now, I need to use a mathematical manipulation to create, please take note, the manipulation happens to create this sine squared alpha and the minus cos squared alpha. To create it, you need to multiply. You need to multiply this sine alpha minus cos alpha by the conjugate of itself divided by the conjugate of itself, which is equal to 1 overall. And then you have a difference of 2 squares. If you use FOIL, then you come to that. Okay? And then you are done. Okay?